Hey guys, give me a 5 for 5 and we'll get rocking. Hope everybody's doing okay today. Hope everybody's having a great, wonderful day. And, yeah. Oh, yeah. What's up, Rick? How you doing? How's everybody in there? All right, cool. Hey, I'm going to take somebody's suggestion. I can't remember who suggested it. Hey, Tab, what's up? Why don't you have a wrench? Tab? What happened to your wrench? There. What happened to your wrench there, girl? That's odd. Are you on a different account? Just curious. But, yeah, so I'm going to take the suggestion that I seen in the comment section. I want to go over what the main piece of the main meat of the video is going to be right at the beginning. Okay? Oh, really? Okay. Well, there's your wrench back. Sorry to hear that, by the way. Yeah, that sucks. I don't know what to say about that. That's a tough thing to deal with there. Hey, Christine, what's up? Seven's in the house. So, all right. So I am going to take this opportunity to go ahead and act on a criticism that was given. And that was that I kind of jump around a whole lot, and I need to get to the meat of it right at the beginning. I actually agree with that. I know watching YouTube or any other video, I don't like going to people's video and they wait till the end. I never do that intentionally, but it does seem to happen quite a bit. So I'm going to try to get to it right here at the beginning. Whatever's in my thumbnail, I'll talk about it first. So we're going to do that right now. Obviously, we had a solar storm fire off back on the 28th. So what we'll do is we will go over here to seeds real quick and go back to that. That's what this is right here. This is stereo A. Remember, this is our partial side view of the sun. This is two-dimensional. I'm not going to take you to my three-dimensional one right now, but satellite would be right here where my cursor is. Actually, I'll just zoom in a little bit here. That's probably a little bit better. But anyway, satellite here, Earth would be over here. Now, you don't know exactly what kind of... That's not a 90-degree angle, by the way. We don't know the angle because of it's a two-dimensional thing, graphic that we're looking at. So if the satellite's here, Earth is here, but it's still a 45 between us and them, us and the satellite, okay? But we're on the same plane horizontally. So this thing is definitely coming at us, and that's what I've been saying since this thing fired off. Now, whether or not it was going to hit us or not, there was always question. Now, there's the same model is used throughout multiple different agencies. They take the same data, but they input into the same model, but they can change the parameters in that model. What model am I talking about? Well, this is the most popular one that they use. This is the Enlil spiral. Okay? So what this is this is going to show you exactly what they think is going to happen. Now, this is NOAA. This is NOAA's version of it, and I'll show you NASA's here in a minute. But this one here, and I've been saying that for a minute here on this one I think it was more correct than most of them this time around. All right? So what I'll do is I'll go ahead and zoom in a little bit more so we can kind of see what's actually happening. So when you see these this is a top-down view, by the way. Sun, Earth, this is side view. So what I'll do is, let me click on that first, and then I think I can move it with my cursor. Hey, Helen, what's up? Thank you. So I'll back this up a little bit to where it starts. Now remember, this thing will tell us what happened 2 days prior, and they try to forecast 5 days out in advance. Now something that's going on right here with this model, they haven't really changed it, or they're not showing the data change yet. Typically they update this thing quite often. This time it hasn't been updated for a minute, because obviously right now we're right here. Well, actually what is today's the 30th, right? Yeah. So we're close to right here where they said this thing was going to hit. So they haven't really updated this since then. But I do think that this, what they showed 3 days ago, is actually probably what's happening. So anyway, as we do this, you'll see the CME start firing off the sun here. I'm gonna say something here too. CME, solar flare, they're different. Okay, and I keep saying that, and unfortunately, you still got people out there saying that they don't understand the difference. I get it if you're a subscriber or a listener, but if you're going to be out here presenting this kind of information, please know the difference. I didn't used to. I used to make the same mistake, but once I was corrected, I never made that mistake again. And unfortunately, we got people out there that have been corrected and still continue to just ignore it. But anyway, a solar flare, you get the X-rays here in about 8 minutes. Typically, that's the initial impact. Now, sometimes there'll be a CME with the larger flares. They're two different things. Okay? But anyway, as you can see here, actually, I need to do this again. Sorry. Watch right here. You're going to see two different eruptions or two different CMEs. See how that one fired off and then the one right behind it. See that? That's exactly what happened. Now, I'm showing you this for a reason because this could come into play. Because as you can see, the one behind it was the stronger one. It's moving faster. See that? See how it caught up? Now, what's going to determine how hard we get hit with this is going to be whether or not they kind of combined. Sometimes that happens. The energy just kind of melds into one, and it can make it stronger. One thing's for sure, when it did catch up right there, there was probably what we call an interplanetary magnetic shock wave. It's not going to affect us because it's far enough away when it happens. But if that happens right when it hits Earth, what happens is the atoms and stuff in there, the particles, they have their own magnetic field, right? So believe it or not, they're not actually colliding with each other. What happens is they're actually repelling. And that's more common than the actual, when you crash an atom into one another, that's a very violent thing. Look at all the particle colliders on our planet. The biggest one we talk about starts with the C, ends with an urn. Okay? But that's most definitely would be powerful. So that's what I'm saying here is it's much more likely that you see those repelling effects than you do a collision. Because it takes a lot of energy to collide two particles together. And not that it doesn't happen, because it most certainly does with stuff like this. But the majority of that stuff you're going to see is from an actual repel effect. You get your positive against a positive, and they push against each other. So that's kind of what I'm talking about. But that shockwave probably did happen back there, but it didn't happen here at our planet. But it looks like they've kind of combined into one kind of event here. Now, there was some question whether or not this was going to sideswipe us, whether it was coming right at us, whatever. Well, I can tell you for sure right now that we are being impacted by it right now. The beginnings of it. So, and I'll show you that here in just a second. Now, with that being said, the timing of it is lining up with this model. The other models weren't quite on the same time frame. So that's lending to the effect that this one may be the more correct one at the end of the day. Now, we're just going to have to wait. Hey, Rippy, what's up? What's up, Linda? 7, what's happening? So, yeah. Now, remember, this is speed down here. I show you the density one because people can see it better on here. It's just more visible. That's the only reason why I show it here. But as you can tell, back then they were saying that the density could actually get close to 50. That's a pretty substantial density hit. And you throw in, 400, 500, 600, 700 kilometers a second wind speed with that kind of density, you're talking a pretty substantial smack. Now, whether or not that's exactly what happens when this actually does hit, it's hitting now. Okay, how do I know that? Well, you can go look at the data here. But we're going to start up here first. This is the X-ray, and obviously this isn't what would be hitting us now unless it was from a different flare. So there's nothing going on right here. We had a couple flares back here, but there was really no more eruptions from CME plasma or any kind of filament release coming at us. But as you can see, geomagnetically, see how we took a spike right here? Now I know we popped down again, but this is kind of normal. Usually we'll get an initial, hey, we spiked up. We'll kind of tail off for a second, and then we'll really get hit. What happens is they kind of, it's almost like a wave. It's like when the water's pushing up against the shore, you get that buildup of water in front of it. And that's kind of what it does with solar wind in CMEs. Okay, so that's kind of what I think is happening here. I do look for, if not this next plot point here, the very next one, I think we'll probably at least be back up to a 4 and possibly into storm level by then. Their forecasting, I think, was for it to happen. Let's see here. I think it was at the beginning of the day here. Yeah. So here in the next 3 hours, we should be experiencing G1 storm level, according to their forecasting. Now, if you look back here to these were pretty close in their accuracy. If you look right here, compare these two. So I think that this one's going to be pretty close this time. Now, with that being said, it does look like it may have arrived just a touch early. That could mean that it could be a little bit stronger, or it could mean absolutely nothing. It may not be enough to really significantly change what we're seeing, right? So as we see this, that's what you're going to look at. You get the G1 storms. What do we get with G1 storms? Well, let's go take a look at that real quick. I believe I might have it here. Yep, there it is. Okay. I showed you guys this the other day, and I pulled this out quite a bit. So we got geomagnetic storms here. What can we expect with a G1? Weak power grid fluctuations, minor impacts on satellite operations. Migratory animals are affected at this and higher levels. Aurora is commonly visible at high latitudes. What's high latitude? See, notice they put Michigan and Maine. What they failed to put here was New Zealand and further south. Okay, because what needs to happen here is the closer you get to the poles is where you see more and more aurora. That's what they mean by high latitude. The further away you get from the equator, the higher your latitude is. Whether it's negative or positive, it's still considered higher latitude. So that's what you're talking about there. Now, if we do get to level 2, you say high latitude power systems may get some voltage alarms. Long duration ones can cause some transformer damage. We're talking high latitudes, guys. Okay, we're talking probably Canada north. As far as if you're over here in the USA. And shout out to all my international subscribers. Good to see you guys. You guys are in here. Aussie, 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 baby. And, my friends from over across the pond in the UK and everywhere else. Philippines, New Zealand, like I mentioned before. I got people that watch in Korea, Vietnam, China. All over the world, guys. Croatia. So, it's I feel very, very blessed and honored that people even want to listen. So, it's a very cool thing for me. But anyway, that's what you guys can kind of expect if we get into this stuff. Now, I don't think we're going to get any higher. Now, I say that with saying this, that there's always a chance. Always. But, like I said before, given that the timing of this one was correct this time, most likely this one here is going to be the more correct of the model. So let's take a look at the data on Discover, and this is the actual data plot points that I show you guys all the time. And you can definitely see, now remember what I said, when you start seeing a decrease in density, you're going to see an increase in the wind speed typically. That's exactly what you're seeing. The orange is the density, the purple is the wind speed. And 3 to 500 on the purple one there, the wind speed, kilometers per second, it's definitely above 500. Now, this could get faster. Who knows? I don't know. Again, we have to wait. Now, like I said, given that timing, the NOAA model seems to be pretty correct. So whether or not we take a nice big hard hit from this is probably going to greatly depend on how dense this was. Okay? Also, it's going to depend on whether or not our BZ starts to tip down south. Remember, when the angle of our magnetic field there is tilted more towards the south, which is what we say -6, that's what we look for, right? That means it's easier for the stuff to get in. We take harder hits. When it's facing more towards the north, well, sometimes that actually kind of deflects it. So, hey, Jan, what's up? Karen, what's happening? Judith, Tammy, PCN, what's up? Linda. Okay, so with that being said, that's your data for that kind of for the CME part of it. Now, again, I wanted to go over that right at the get, just so everybody could. That's what the thumbnail said in it. I'm going to try to do that for you guys. You can see here on our magnometers, they started moving. See how kind of flatline they were here for the past couple days? Well, they started moving as soon as we started getting the increase here. So, yeah. Now, this is the magnetopause models. This is the velocity, kilometers per second. And we'll go ahead and run this. Actually, I think I'm going to update that because sometimes it changes. Remember on the velocity one here, the red color would be the faster of all of it, right? Faster color. Sun's off to the left, moving from left to right. This is our magnetopause. This is kind of representing our bow shock. It's probably not exact, but the bow shock is just the point where solar wind meets our magnetic field, or a magnetic field, actually. It produces a bow shock like that. And what it does is, this is actually helping deflect a lot of this. We'll absorb some of it, and some of it gets through, okay? You'll notice that the speed and the density typically is lower inside of our magnetopause, behind this bow shock. That is our protection. That's our magnetic field. Now, when you're looking here on the left, this is a top-down view, okay? On the right, that's a side cut. So you have to understand that too. So this is as if we're looking down at the Earth. This one here would be looking at the side. And again, sun off to the left. So you see when you see the blues, that's actually moving just as fast as the reds. It's just moving the opposite direction. It's different polarity. Okay? So that's kind of what that is trying to represent. Remember, all that stuff has polarity. It's charged gas, plasma. So it has a charge, and it stays on a magnetic connection line. That's what they do. That's how they travel. Now, the further away they spiral away from that line, the less dense the hit is. But they typically move faster when that happens. So that's just a little bit of whatever there. Kind of, I guess, just to help people understand more how the mechanics of that works. Now, this is density. Did I stop that? Yeah, okay. You got the density here. Again, darker blue, more dense. Light blue, less dense. So it makes sense that you would have the less dense particles inside of our protection, right? That's what's happening here. And again, this is a very basic. I'm not going into depth here on anything. It does no good to do that in this kind of a forum because I end up confusing people. I try to bring it, to so where everybody can understand it, and I hope you guys do. I try my best with that. I try to really not go too, technical with it, but I don't want to go too not technical also, because I don't want to seem like I'm talking down to people. That's never my intent. I just want everybody to understand. So anybody can understand pressure, right? Obviously. Well, this is magnetic pressure. You see that? That was the first initial hit. And you're going to see this stuff. It's probably going to continue. The only thing that's kind of got me iffy whether or not this is going to continue is that the angle of it wasn't exactly forecasted like they said, right? The timing of it's definitely happening. It's happening just like they said right now. But whether the angle's there, again, that's one of those things we're just never 100% till it happens. Hey, Ricky. What's up, Vicky? So again, this is the side view. So what we'll do is we'll look at the front view from the same day. So this is why everybody thinks it's mainly, not everybody. Most people think that this is more of a direct hit than what I thought even, from what I'm seeing. Okay, from their forecasting to these models, everything. This is a halo, partial halo, what we talk about, right? Remember, this is from our perspective. This satellite sits out in front of the Earth about 1 million miles closer to the sun. This is on SOHO. It's always looking at the sun, and it stays out in front of Earth as we orbit around the sun. So it's always looking at the sun. So it's from our viewpoint. So when you see this halo action, that's why we go look at the other view, so we can see a side cut of it. When we're looking at it front on, we don't know if it's going straight towards the back, because I've shown you guys big blasts that look like it's going to like really hit us real hard, but it's actually going the opposite direction and not going to affect us at all. So when you see these big halos, that's why you absolutely need to go look at the other view. But do you see how this stretched out? Even though it blew off over here, it spread out like that. So that is a more of a horizontal spread, which is a latitude spread there. You know, and then north-south, there's no way we're going to miss it north-south, I don't think. It's up too far north up here. So this is why I think that this is really going to, you know, we're going to take a hit from this. Now, again, even though we get hit directly, please don't over-sensationalize this to the point where people are, like, getting scared and stuff, because this is nothing to be fearful of whatsoever. Okay? So just understand that. If it's time to be, like, concerned, that's the first thing that's going to come out of my mouth, guys. Okay? This is not a concern. This is something that we just need to pay attention to, because it helps us understand when we need to be concerned. That's the point of showing people these kinds of things. It's not to entice fear. It's not to over sensationalize it so you can get clicks and views. And, you know, I don't have a problem with somebody like, I guess, goosing up their title a little bit, putting some cool pictures in the thumbnail. You know, that's okay, because you're bringing in, you know, other people that might not necessarily click, right? But you can't make it such a over-the-top thing that you're not even close to what your thumbnail or your title said. We all want to be enticed. If it's not entertaining at all, we're not going to watch. Sorry. That's a fact. I don't care who says any different than that. That's a fact. If you're not going to get entertained, you're not going to watch it. Because I don't know many people that hop onto YouTube saying, man, I'm going to go find something that I can learn from, but it's going to be so dead boring that, you know, I still want to go watch, though. No, it's not going to happen. Unless you're taking some sort of classes or something. But what I'm saying is, this is why we show stuff like this in the way, at least the way that I do it. So, well, thank you. Is that Reedy? Reedy82? Thank you for that. Appreciate that, guys. I really do. Those kinds of comments are the way, you know, Reedy here says, I understand you. I've watched you for a year. I don't yak while you're talking, so I hear you. Understood. I appreciate your informative videos. Sorry. I appreciate those kinds of comments, guys. You know, I get enough negative ones. Those are the ones that keep me around, just so you understand. So, yeah. Now, we'll go over here to SDO. Now, I'm going to take you back to that day. All right? And this will give us a 3-day run, which is why I like using SDO instead of ISWA. It's the same satellite, same imaging. It's just on a different format. Over there, you can only go back 300 images. And I think they're in 4-minute increments. So you get one capture every 4 minutes. This here is a lot more in-depth, and it gives you way more imaging. This is a 3-day lapse. Did you guys see that on the end right there? That happened today, by the way. Okay? I'll show it to you again. Let me pause this. I'm going to take this back, and we're going to slow it down just a touch. Okay, here's the one we're talking about right now. Watch right here where my cursor is. See it? See how far it blew out this way? So that's why I think it's going to come at us. Now, watch up here. We're going to get another one up here. It wasn't too long ago when this one happened. It's not showing up on the coronagraphs yet, but I think it probably will. It's getting ready. I slowed it down, guys. I just want you guys to be able to see it. It's going to come from this sunspot. Don't worry about that shaking. Happens all the time. Most likely it's a corrective roll that they do to calibrate it. But watch right here. I know it's taking a minute. Sorry. See that? See how that pushed off right there? Now, I'm not sure if that left the sun or not. I haven't been able to see it on the coronagraph yet. So, just wondering. So yeah, yeah. But just what, so yeah. Oh, goodness. Surely no, I'm not a geoscientist whatsoever. Okay? I'm just somebody that thought this was an interesting subject, and I dove into it a few years back, and I've been helped by a lot of different people on both sides of the conversation. Help me understand what I'm trying to explain. So yeah, yeah, Seven. Don't worry. I mean, as long as she's not being disrespectful, I don't know that she was. I don't know. We'll go back and look at that, but that's fine. I mean, you could think I'm not valid. I'm not trying to. First off, let me say this: I'm not trying to validate anybody or validate myself through anything I say. I'm just trying to show you what I see and how I understand it. And I say straight from the get, I have no secondary education in this. This is just something I enjoyed doing, and I'm able to share at a basic level. And I encourage everybody to look at everybody's channel, everybody's information. There's something real neat though. You know what that real neat thing is? There is an X up there in the top of your window. You can actually click on that. So if it's not, correct information or whatever, if you think it's not what it's supposed to be, I would encourage you to hit that X, because it might help you not have to worry about me being validated. Anyway, we will go over here to the Aurora. Well, let's go to the geomagnetic field model. Anyway, so you got the this is right here would be Spaceweather's effect on our electrical grid. And this is just their model that they're using. It is a good representation in my opinion. This is a 3-dimensional one, and this is 2-dimensional. When they get this one done, this will be an awesome one. You're going to notice that you're going to see more activity around higher populated areas, and the reason being is there's more electrical components in those areas. So, yeah. Yeah, Pam, or PCM, we'll go check that out here in a minute. But, yeah, so if you're looking at that, all's good. I don't see anything big here. It is upticked. We know that. Typically, this stays at a very, very light color blue. When we start getting up into these other colors, yes, we've seen stuff really blast this before. Remember, our magnetic field is not a complete, consistent blanket over our planet, right? It is more so like your grandma's Afghan. It is different thicknesses. It has holes in it. It has cracks, much like my butt. Got a big crack in it right down the middle of it. But yeah, so when you're looking at this, that's what you got to keep in mind. When you're looking at anything dealing with the magnetic field, it is not a very consistent thing. It's all over the place. And we can even go down to the South Atlantic anomaly and talk about that. That right there, it's thought that it's the same way over like Bermuda, the Bermuda Triangle. And I do think there might be some truth to that, where the magnetics are kind of jacked up. There's multiple places around our planet that it's like that. So it messes with navigation. Really does. So, I just want to miss something here. Make sure I've got everything covered here for you guys. So, let's go over here to, let's go to the earthquakes first. And again, guys, I am not the earthquake guy. This is just me showing you the earthquakes we have right now. I've learned that, if I'm not going to be able to help anybody understand this any greater than what, a typical understanding is, I'm just not even going to say it. And so I'm not comfortable enough trying to say, hey, this is going to happen here, this is going to happen here, and this is why. Ricky's in here. She knows a lot about earthquakes, plus the other channels that I suggest you guys go to. Some of those are in my description box, so go check them out. But yeah, I say this every video so people understand that I am not the earthquake guy. I'm just going to show you observation. So, as you got this plot right here, that's up in Alaska, right? So, was there any tsunami? No, no box there. That was the most recent one, right? Now, I will say that this doesn't look very active right now, which is kind of odd to me. It's not extremely odd, but usually, you know, we get a little bit more than what we're seeing right there on a daily basis. Now, if I add all magnitudes, this is going to change, right? That's what I just did right there. Now, notice I want to show you this key too, because some people forget about this. All magnitudes, US. Doesn't say world. So they don't have they got a 30-day all magnitude US, 30-day, 4.5, 30-day 2.5. They don't have a 30-day all magnitude. So I can't show you every earthquake on here, right? And that's my point. I'll be able to show you these. That's pretty much it. Looks like one just popped off in Alaska. When did that happen? That just happened too long ago. Okay, that's a 5-1. So it looks like we might have some sort of a little bit of an event there. That was, yeah, those happen 15 minutes apart. Obviously, they're related. But it's like that. Might be a swarm or something starting there. You can definitely see the swarming here and here. Obviously, lots of volcanoes popping off. You guys can research or just type in, volcanic lightning. Yeah, you're right, Wendy. It's and that's the thing, guys. I didn't get into space weather either until we were already in solar minimum. All right, and she's talking about how the sun looks right now, and what it's because we're deep, not deep. We are definitely in solar cycle 25 now. With that being said, this is going to be more the norm. The solar flux is up over 100, and it's going to stay that way for an extended period of time. That's something we ain't seen in years. So the solar flux is basically, a reflection of the X-ray flux. When you see these sunspots, they are producing X-rays, even when they're not flaring. Okay? So the more sunspots we got, the more baseline X-ray will rise. Okay, when we talked about this a long time ago, when our base was down here below the A flare range. So it would take a substantial flare to really get us up in here. If we're up here right now, hanging right at a high B, low C range, it doesn't take much more of a flare to get us up into these ranges. So that's kind of what we're talking about there. That's why it matters. We could sit here and talk about radio propagation and all kinds of stuff like that. And it's a big deal for ham radio operators when we start getting solar storms and all that. Plus, astrophotographers love to get aurora shots and stuff happening out in space, and they're beautiful stuff, man. So that matters to them a lot. So that's why we talk about it. Christine, you're typing in a different language, girl. What's going on with that? Was somebody in there talking in that language you're trying to talk to them? Huh. Didn't know that, Scott. Interesting. Power just went out, huh, Dana? What region are you in? Hey, Verte, what's up? Dana, what region are you in? You ain't got to tell me exact. Just give me some sort of a regional area. But yeah, there's actually, we can do this too. Hold on. I think I got a, let's see here. I know I had an outage map. There it is. This is, you guys can go to this anytime you want to. And again, I've shown you guys this multiple times. Right now, Texas and California, Obviously, they got some stuff going on down there. 16,000 without power down there. 10,000 in California. And obviously, these are highly populated states. So, I mean, that's really not all that out of the ordinary for down there. So, yeah. Okay. So, let's go over to spaceweather.com. If you guys don't know what this is, you haven't watched me at all. Just saying. I think you guys hear every video. So, oh, and by the way, you know, after the space weather report's pretty much done after that, and we'll talk about other stuff here in a few minutes. But yeah, so let's go over to spaceweather.com, and what do you got? Well, you got Aurora, lots of it, and this is going to increase probably right now as we're talking. I think it's definitely going to be on a steady uptick. And what I think her name was Wendy. I'm sorry if I'm saying the wrong name here. The sunspots. This is a really good place. You can go to these over here at ISWA too. You can get to these anywhere pretty much, right? So as you're looking at this, you got 2880. This one here up is we're going to have to keep our eye on this one. Just saying. The properties around the sunspots on the surface there are in such a way that this thing could start producing M flares pretty quick, if not bigger. The one that popped off over here from this one, this isn't the one we're getting the energy from right now. It was this one, 2871. This one was decaying and rotating off. This one here is showing some pretty strong characteristics. Remember what I said, they got to have some people in the sandbox playing with them. So what I'm talking about there, it can't just be one little sunspot or even a big one. If it don't have friends to interact with, it will never flare. Hardly ever. Okay? So you have to have that interaction and that, you know, basically they positive and negative, they cross and all that, just like we talk about with magnetism or electricity even. And that's what causes that stuff. Yeah, it's Beta Delta. Yep. Oh, man. So, Rick, I think you did that by accident, just so you know. I just say it out there for you, Rip. I think you did that on accident, I'm pretty sure. But anyway, so let's go ahead and go back to spaceweather.com. And this was really interesting because this aurora you're seeing here, they're saying was actually produced by the Earth itself. This is something they've been studying. And we've talked about this briefly before, but I'm not going to go into detail tonight, but you can definitely see. This is actually, they're saying this energy here actually was caused by the Earth itself. Says Earth can make its own aurora. You guys can read this. I would definitely encourage you to do so. I'm not going to do that because I would rather you guys go check it out for yourself over here at spaceweather.com. Matter of fact, let's do this. It's in my description every video, guys. Spaceweather.com. If you guys really should check them out. It's just such a well put together. It's very reliable on the information you get over here. So just understand that. That's definitely where I would point you. Now again, back to the sunspots. This really shows you. Now this is from GOES. Okay, this is similar to SDO. It's still an extreme ultraviolet imager, right? It's just on a different satellite. GOES 16, GOES 17, we all know about those because those are weather satellites too, right? But they also double and use this and do this also. So something else I want to point out: the coronal holes are becoming pretty dominant. Also, they have for the past few weeks. So just want to say that, yeah. But you can see the spots. Look at the ones starting to rotate over the limb now. And also remember on the sun, east and west are reversed. North-south's the same, but when you're talking about the sun, we would call this the east limb. Now, they named it that way, way back in the day. I'm not sure exactly why they did it that way, but they just never changed it back because there was so much data and stuff collected. Trying to, change something in the middle like that would probably confuse some of the data and how people seen it. Yeah, guys, I would, again, this is my opinion. I can't say for anything on anything other than that. I would highly discourage you from going outside and looking at the sun without any protection. I know that there's, other ideas there, and I'm not judging anybody. It's just from my opinion, from what I understand, and from what I would do. You wouldn't see me go outside and look directly at the sun. Now, I know there's some sun gazers, and I get why they do it. I understand why too. It's just something that I don't do, and I personally would not recommend. But that's just me. Thought I'd put that out there. It's an interesting subject if anybody wants to research that. I mean, there is, from some of the studies, they say that there's some benefit and stuff to that, but I'm not sure if the risk would outweigh that benefit. I'm not sure. I'm just not going to do it. But anyway, over here, near Earth objects, lunar distance. That's the distance between us and the moon. That's how they measure these things. Nothing really much going on. Now this one here, small, 4 meters, right? That's 4 yardsticks. Roughly what? What would that be? 12 feet? Okay. So yeah, they call that sun gazing, Jeff. That people do that. I'm not kidding. And I know it sounds really, really like wow, but again, I'm not versed enough even to really give you a good, strong opinion on that, other than to say I personally wouldn't do it. So anyway, you got 6 meters here, which is 18 feet. So yeah. But yeah. I'm doing all right, Jack. Yeah, I'm not sure if you guys are in there. Yeah, you guys can have discourse, but please don't let it get nasty. That's all I ask. Believe me, I know my subscribers, they can take care of themselves, and anybody else here also. I welcome everybody who wants to listen as long as they're respectful. That's all. And again, yeah. Believe me, it's hard for my mods not to, and I'm coming to their defense on this because they want to protect me and protect the channel, and that's why they sometimes, get certain comments out of there. It's hard for them, is what I'm trying to say. Especially when somebody's like going at them, they're having discussion or whatever. So I get it. I get both sides. But I just want to say my mods do a great job. They have probably the hardest job here on the internet. Just saying. Oh, that's a different... Who? Spirit, light, intelligence, matters, energy. Oh, that Dan? Changed your name, didn't you? What's up? So yeah. Hey Skywalker, what's up? But as far as that goes, guys, that is the space weather report. Actually, I'm going to add that into here right now. That's actually about right. So I'll just leave it there. But is there anything that you guys want me to cover? Now, I've been researching some stuff for a long time on a lot of different subjects and stuff. And I know that people have asked me and asked me and asked me to talk about certain things. So is there, as far as, well, I have these two pulled up. This is moon data, right? This is actually about our Earth and how everything kind of plays together. But this is a axial tilt is basically what this is talking about. But in order to move forward with any kind of conversation like this one, we have to understand vocabulary words. I know it sucks. I get it. And I try to really bring it down to a level. But is this something you guys want to talk about? If it is, cool. If not, I'll skip it. Not a big deal to me. There is some, like I said, when we're talking about axial tilt, I went over that quite a bit. But there's some questions on certain things, and I can show you both sides. I can do all kinds of stuff here. I'm just reading, guys, trying to catch up. Yes, Becca makes a good point. The UV, okay? Back until about 3 years ago, even in the textbooks, it would tell you that we could not get UVC at the surface from a natural source. Okay? It was thought that would never be able to get to the surface unless it came from like a welding machine or, when people get what they call a welder's burn in their eyes, that's basically what's doing it. They're looking at that weld as they're welding it, and it burns their eyes, and that's why. So about 3 years ago, they started picking up UVC on the surface of the Earth. So that means it was making it all the way through the atmosphere and to the surface to us. At the small doses that it's happening right now isn't such a big deal, okay? But if that trend continues, and it most likely will, I'm not sure how long it'll be or if it'll reverse and go back the other way. I don't know. But I can say this, that they are picking up those readings now. Now, the only thing we can do to protect ourselves from UVC is to cover our skin. Yeah, Jack, I would say, and it's my opinion, I think that our magnetic field, and it's not just an opinion there, guys, it's a data-backed opinion as far as how weak our magnetic field is. Now, however that's going to affect us, that's where the question is, okay? I don't think it's much of a question whether or not it has weakened. Now, I know there are some out there that say that it hasn't, but, the data I've seen and what I look at, it tells me that, yes, it has. But how that's going to affect us in the future, how great it will, or is it better or worse? I mean, there's questions on that. There's a whole, everything is questioned. Just understand that. Hey, Whitetail. That's possible, Dan. Spirit Light. Okay. I don't, there is a time frame there, and he's talking about a pole flip. And the thing I would say there on the pole flip, hey Mark, what's up? Menacing, what's happening? Yeah, I'm sure we do. I haven't looked at it lately. I know we do. I've shown it. But again, there's always that question, is the data collection correct, or is it really that bad, or what? Nobody. We got to pick and choose who we go to for our data. And it ain't like all of us have stuff in our backyard. That's my point. And I know that certain things get questioned because of where the information comes from. This one here in particular takes a hard hit a lot. But yeah, I mean, I really don't know what to say in those kinds of situations. Other than to say that there's not much choice that we have than to look at that data. But yes, they do show that our magnetic field is weakened. There's really not much question. There are people out there that don't think that that's the case, but I personally do. And again, I can show you the graph. I have to go look at it, but it's roughly 25% weaker. Yeah, staying out of the sun's always a good idea anyway, at least the main part of the day for long term. Okay, just so you guys understand that. I do believe that 100%. But yeah. Are you out here, Ricky? Good to see you. Thanks for stopping in. But yeah. And don't be afraid or be embarrassed to take a umbrella outside with you. No. Missing. The question there is, does cloud cover protect us from UV? There's actually a phenomenon there that some think that it could actually increase it because it changes the angle of the way the light and stuff's coming through. Now, there's a lot of different studies on that, and I can't speak too much to that because I just don't know. But yeah, so again, yeah. Have to get okay. See you, Jan. Thanks for stopping in. I have no idea, Linda. Not on that one. I really don't. Yeah, I mean, don't be afraid to grab an umbrella. Kathleen, what's happening? Yep, you can. That's actually kind of my point, Becca. No, it doesn't. Cloud cover ain't going to protect you from UV. Not in any significant way. Okay? Now, obviously, if it's raining, the best thing for radiation, just so you guys know, one of the most popular things we could point to block radiation, believe it or not, it's water. So if you've got rain, obviously, what are clouds? It's water vapor. Thanks, Stephen. Appreciate you. Yeah, I mean, the umbrella thing is, people just are too embarrassed, I think, is what it is, or inconvenienced. And don't get me wrong, I mean, I catch myself being like that too. But yeah, so I mean, again, guys, is there anything you guys want to, just if you want me to cover a certain whatever subject, I can probably do that. But as far as this goes, we need to understand if we're going to use certain terms, we got to use stuff like, this is I can't even say the stupid word. Eccentricity. Okay, basically, it's our orbital shape around the sun is not exactly a circle. Okay, there's times that we're closer or further away. It's in a 100,000 year cycle, though. It's a known cycle. And this right here, this movement here, is greatly exaggerated. They did this so you could even see it. So I'll play it. You see how it's moving? But that's greatly exaggerated. Matter of fact, it says it is. So we can see it. It's such a small movement that it's almost, yeah. But then we need to understand here, obliquity. This is not wobble. Most people are talking about Earth wobble. They're thinking that our Earth is like going all over the place. No. This is obliquity. This is tilt. Right? So, then we can go down here. This is what most people think wobble is, or don't know that this is what wobble is. Wobble is this axis. See this axis right here that we spin on? This is not our axis. This is. Right? So the wobble they're talking about is this motion. And it's in a 26,000 year cycle, guys. So, this is one of the main reasons why the North Pole star has to change. Because we're pointed a different direction throughout wobble. 26,000 year cycle. So, yeah. So when you hear somebody say Earth, or the Earth's wobbling, most of them are talking about this. They think this is what the wobble is, and it's not. It's obliquity. Or tilt is obliquity. This is Earth wobble. Sorry about that, guys. But yeah, guys, and again, there's some big subjects out there. I've been researching, for months now. And I will be bringing that information to you guys. I need to make sure I'm right in what I'm saying and talking about. So look for that. That's going to happen. And I'm going to start by talking about stuff like this and getting people to understand the definitions first and foremost. Okay? So that's coming. That's what I'm working on. So yeah, guys. So with that being said, I think I am going to go ahead and kill it. Thanks for everybody stopping through. If we do get into storm level, I'll probably pop back on and give you a short update. But as of right now, we won't see it until this next block or even the next 3 hours. Probably within the next 6 to 12 hours, we'll probably be in a storm level. That's just my guess. So, but we're going to go ahead and end it there. I will catch you guys later. And hope everybody stays safe. So, yeah, don't panic, guys. Never. That's why I do what I do here. I don't want anybody panicking whatsoever. Okay? What's up, Judith? Thanks for stopping in, Leisure. Appreciate your help, man. Whitetail, what's going on? Mark Webb, what's happening? So, yeah. Hey, Tom, what's up, man? Good to see you. Conspiracy Realist, what's happening? Cheryl. DCU. Okay, guys. But, yeah. Don't panic, please. There's no panic. There's no fear. There's no reason to. Okay? We can't control it anyway, guys. We just got to be aware. And then when it does come time where we need to take action, then we'll make better decisions because we're not going to be scared. We're going to know that this was always a possibility. So when it does happen, we'll make way better decisions for ourselves. Just saying. But also, before I get out of here, guys, obviously, please go check out the lifeboat. Again, it has nothing to do with Spaceweather. It's we talk about addiction recovery over there, and Tommy's doing a great job. I'm helping him in the background. It's become a family over there. Immediately, I mean, it's something to see. But Please go over there to the lifeboat, check it out. Description, the link to that's in the description box. Also, please support Mark Pires. He's struggling with what he wants to do with this channel, so he could use some prayers and all that kind of thing. And go check him out, Mark Pires, Renaissance Man. Again, descriptions links in the description box. So both great channels, guys. Positive stuff all around. So anyway, guys, God bless. Yahusha saves, and you can drink this Kool-Aid.